Hey guys, I'm going to do a quick review of arithmetic sequences. Shouldn't take too long. I have one little thing at the end that we didn't talk about last year that I just need to make sure we know how to do. It'll take all of 30 seconds. It's just scientific notation. So just kind of watch. I doubt you'll need to take too many notes. Just pay attention or skim through it. So remember, arithmetic sequences are sequences. It's a pattern of numbers where you are adding by a constant number each time or subtracting by a constant number each time. These are the two formulas. This is the general form where un, so some nth term in the sequence, is equal to the first term plus n minus 1 times d, where d is the common difference. And then over here we have our summation formula. Both of these are on the formula sheet and it's written this way, but in reality they're the exact same thing. Like if you replace this u sub n with this right here, you can see that if you substituted that in, you'd get this expression. So they're the same thing. So let's do some examples. So we have this first one. We have find the 12th term. So we say, oh, come on, please. That's nice. Just let me draw. Thank you. So if we want the 12th term, we say u sub 12 equals the first term, 13, plus 12 minus 1 times 6, because that's our common difference. It's hard to do with your finger. So that's really just 13 plus 11 times 6 is 66. So 79. Easy enough. Then an expression for the nth term would just be even easier. It's just u sub n equals first term plus n minus 1 times 6. And if we wanted to simplify that by distributing the 6, you would get, so 6n, and then you'd get 13 minus 6. So 6, oh no. I wish I could use a stylus. 6n plus 7. There you go. So, example 2, find the number of terms in this sequence. So the difference between this one and the last one is we don't know n on this one, but we know our theoretical nth term is 12. So we're going to say 12 is equal to first term plus n minus 1, which we don't know n, that's what we're trying to solve for. And then make sure you don't mess up this silly thing. D on this one, since we are subtracting, is negative 3. So now all we got to do is basic algebra, solve for n. So we have 12 equals 84 minus 3n plus 3. So what would that be? You'd do 9 minus 84 is negative 75 equals negative 3n. So n equals 25. Voila. Easy enough. Next ones. Okay, here we go. Let's just do these two. This says the 9th term is 48, the 12th term is 75. Find the first term in common difference. I don't want to use the formula on this first one. Let's use some common sense. So we have the 9th term is 48. We don't know the 10th, 11th, but we know the 12th term is 75. So if we're doing arithmetic, that means we added by something 3 times. So this total distance apart is 27. So obviously, what did you add by each time to get there? D equals 9. So now similarly logic, if I want to go from the 9th term back to the first term, how many times do I need to subtract that common difference? well, that would be 8 times. So 48 minus 8 nines is 48 minus 72, which is what, negative 24. So that is our first term. That's really the same thing as using the formula, but I like to think of it as logic, so that's why I said it that way. All right. Calculate the sum of the first 15 terms. So they were nice, said, hey, 15 terms, but we need to know what the 15th term is. So we need to use our general formula first. So U1 plus 15 minus 1 times negative 8. So 14 times negative 8 is negative 112. And that plus 29. Yuck. Come on, computer. There we go. Is negative 83. So that's the 15th term. So now if we want the sum of the first 15 terms, we just do 15 over 2. First term plus the 15th term. So we do that. We get negative 405. You could have immediately, now that I think about it, I just kind of always do it that. You could have immediately plugged into this formula and you'd get the same thing. We really just did it. We just did it as 2 steps. It's the same thing. Okay, so find the number of terms in the series. So we did that same method earlier, where you take the nth term equal to the 4th term. Common difference on this one is 3/2. And you just do some algebra, so 36 equals n minus 1 times 3/2. 36 times, so I want to get rid of this 3/2, so times 2 is 72, and then divided by 3 is 24, and then plus 1 is 25. Right? 72, yeah, 24, yeah, okay. Alright, so now the sum of the terms, we just do sum of 25 equals 25 halves times the first term plus the 25th term. So that is what? So this sum is 64 divided by 2 would be 32, right? And then, I don't know, mental math, so 25 squared is 625, and then you add 25 times 7, which is 175, and you add those together, and you get 800. Okay, and that's the sum. Oops. So now, one more question, then we'll talk about scientific notation, and then I'm done. So, new question, we want S sub n for this. So, S sub n is n over 2. We'll do the second formula since we don't know whatever the nth term is. So we're going to do 2 times 64, so 128. Remember, let me scroll up. I'm using this formula right here. And on this one, U1 is 64, so that's why it's 128. Come on, why are you so fast? Okay, so then plus n minus 1 times negative 4. We could simplify that if we want to, but I don't really care for now. And we want to solve when this is 0. So what I would do is just immediately plug in this this expression right here into y equals on your calculator. And then just use the table to find when it equals 0. So let me do that real fast. Okay, use our table, scroll, oh, need to change my table settings. So it is equal to 0 way down at n equals 33. So there you go. So that's the end of the arithmetic sequence review. Let's talk about scientific notation really fast. It's just something that got added. It used to be in the studies standards, but it got added to the SL and HL standards. So if you want to take an expression and put it into scientific notation, so scientific notation is the form a times 10 to some integer power. So let's say I wanted to take 324,000 and put it into this scientific notation. So that would be 3.24 times 10 to the 5th. Like going back to elementary school math, how many times do you move the decimal? 5 times 10 to the 5th. And so something to note, so in IB we care about 3 significant figures. So if you're ever having to take a large number, this doesn't happen very often, but if you're ever taking, especially on paper 2, if you need to use 3 significant figures, so this would turn into 324,000, and then you would convert it to that. So you don't, when we do our answers, we don't do anything past 3 significant figures. Because these trailing zeros, if you remember from science, aren't significant. All right, so one last thing to make sure you know how to multiply significant, or in this form. So what you would do is you would do 4.1 times 5.3 and get, draw, 21.73. And then you would just multiply the tens, 10 to the 18th. But we don't, that's too many significant figures, and our decimal isn't in the right spot. We only want 1 digit in front of the decimal point. So this turns into 2.17 because I only want 3 significant figures, and then times 10 to the 19th. Well, computer, it's my last number I need to write. That's classic. There we go. Times 10 to the 19th because we moved the decimal one more time. If you were to divide, you would do the same thing. You would subtract the powers, divide the numbers, move the decimal point when needed. Anyway, okay, that's the end of this review. Thank you.